40 seconds.
Stable at step 3.
28.
ECS reduced for launch.
Roger. 25.
Status check.
Go Atlas.
Go Centaur.
Go STP-3.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we have liftoff of the United Launch Alliance Atlas V rocket with the STP-3 mission for the United States Space Force.
Vehicle has cleared the tower and is beginning the pitch over program. And the RD-180 is throttling down slightly as expected. Engine response looks good. And passing 20 seconds into flight, the PU system has gone to closed loop control. SRB chamber pressures continue to look nominal. RD-180 pump speed and fuel injector pressures continue to look good. Mach 1, Atlas V is now supersonic. Passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. And the RD-180 is throttling back up as expected. Engine response looks good. Passing 1 minute into flight, the vehicle is now 9 miles in altitude, 7 miles downrange, traveling at 2,200 miles per hour. And the RD-180 is throttling down again as expected. Engine response looks good. Standing by for SRB burnout shortly. And just past a minute and a half into flight, we have burnout on all 5 SRBs. Burnout pressure signatures are looking good, and the RD-180 is being throttled back up as expected following SRB burnout. Standing by for jettison shortly. And we have good indication of jettison of all 5 SRBs, and the vehicle has gone to closed loop Q alpha limited steering following SRB jettison. Body rates are looking good. And coming up on 2.5 minutes into flight, a little over 2 minutes remaining in the boost phase of flight. And the RD-180 is now throttling to maintain a constant 2.5 G acceleration limit. Engine response and vehicle response looks good. And the Centaur reaction control system is now pressurizing to flight levels. Passing 3 minutes into flight, the RD-180 pump speeds and fuel injector pressures continue to look good. The vehicle body rates look very good for this phase in flight. And the vehicle is now 65 miles in altitude, 150 miles downrange, traveling at 7,800 miles per hour. Standing by for payload fairing jettison shortly. And we have good indication of payload fairing jettison. And we have Centaur forward load reactor deck jettison. And the RD-180 is throttling back up as expected. Engine response looks good. And the RD-180 is now throttling to maintain a constant 5G acceleration limit. Engine response continues to look good. And Centaur has begun the boost phase chill down portion of flight to thermally condition the RL-10 for operation. And we've had BECO, booster engine cutoff, and we've had successful stage separation, and saying pre-start on the RL-10. And we've had ignition for the first burn. This will be the first of 3 Centaur burns for today's mission and will last a little under 6 minutes. The RL-10 startup parameters are looking good, and seeing the body rates close out nicely.
This is Atlas Mission Control at T plus 5 minutes and 21 seconds. You just heard our flight commentator, Jesse Gonzalez, confirm the successful completion of the early phase of today's flight, and all systems continue to operate nominally. Our next event, Centaur main engine cutoff, will occur in approximately 5 minutes. I'm now joined by Emma Coates. She's RUOG's Payload Fairing Program Manager. Thank you so much for being here with us today.
Yes, thanks so much for having me. It's such an accomplishment to be here and to witness the jettison of our first payload fairing, our first out-of-autoclave payload fairing.
Yes, it's been great. I mean,
Yes.
It's a huge accomplishment for the
Exactly.
team, and we're going to talk a lot about what that means out of autoclave manufacturing. But as you know, you guys have been producing payload fairings for us for quite some time,
Yeah.
but this is the first one that we've flown using the out-of-autoclave process.
Yeah.
Can you explain to us a little bit about what that means?
Yeah, so normally when we talk in autoclave or out of autoclave, we're talking about the curing or the baking process that goes into creating creating a payload fairing or composite structure. The autoclave itself is actually the container that is performing this curing or baking process.
Great. So in autoclave versus out of autoclave, what are some of the benefits of the out of autoclave process?
So a few of the benefits of the out of autoclave process is actually the fact that we're able to be a little bit lighter in weight.
We like that.
Right. So we're saving time and cost and everything also because we don't have to have that same internal pressure requirement that's used in the in autoclave process. We're able to lay up an entire half shell of a fairing with just one oven cure cycle, which saves a ton of time.
That's great. I mean, a lot of efficiencies there. We're all about efficiencies and making things better going forward. So what a huge accomplishment and what a fantastic process you just kind of went through for us. So as you know, you have a production facility that also shares our ULA Decatur production facility. This was the first fairing that was actually produced there and flown now. Can you tell us a little bit about the partnership between RUOG and ULA?
Gotcha. Yeah. So we have many years that, as you mentioned before, we've got a ton of years of partnership with ULA, both on our U.S. Switzerland, on our RUOG Switzerland side, and our RUOG U.S. side. But with this being the first one out of Decatur, this actually allowed us to be super close to you guys, sharing that wall essentially. So we were actually able to issue, I guess, better delivery, I guess would be the time frame or be the thing, but we were able to have better delivery times, save on logistics, which is again saving on a ton of costs.
We love the efficiency. Again, we're talking about efficiencies here.
Yeah.
I mean, the one thing that's been great, we obviously talked about process efficiencies, which was awesome, but I mean, you're talking about process flow efficiencies as well.
Yes.
We literally share a wall with our two facilities, so you can't get more efficient than that.
Yeah.
All right, so something near and dear to my heart. I've been lucky enough to work with you on the Vulcan development program for a long time now. As our viewers may not know, you're actually producing the Vulcan payload fairing press as well. So can you give us a little bit of a status on where we're at with that development program?
Sure. So we're actually nearing the completion of our qualification process for that. And of course, we're gathering all of our lessons learned from this launch and any of the other payload fairings we're building as well. That way we can make sure that Vulcan is also a success as well.
Right, and it's been so great to watch that qualification testing that we've been doing at Marshall Space Flight Center. So excited to see that come to completion and fruition and things like that. So it's been really great, you know, learning more about the first out of autoclave fairing. I'm so happy to have you here. Emma, thank you for joining us, and I hope you have a good rest of your day. And again, congratulations.
Thanks so much for having me.
All right. Okay, let's get back to the mission. We're coming up on the end of the first of 3 Centaur engine burns. Our next event is the first Centaur main engine cutoff for MECO 1. Once again, here's Jesse Gonzalez.
And standing by for MECO 1 shortly. And seeing PU go to open loop control in preparation for MECO. And we have MECO. Engine cutoff pressure signatures look good. The Centaur will coast for approximately 1 hour prior to the next burn. And the RCS system is now commanding 100% settling to settle propellants in the tank following the burn.